Well, it's great to be here. I'm sorry I couldn't have been here for the other 2 days, but my life's got very pressured in recent years for reasons I don't fully understand, but it's something to do with the media, I think. So it is nice to be here, and I'll just say a few things about myself. I'm a professor of neuropsychopharmacology, which is the study of drugs in the brain. I'm a psychiatrist, I treat patients, but I've researched drugs in the brain, and it's particularly nice to be here because the first time I ever understood that a drug might change brain function was when I was 15, and I read, my father showed me this piece that Hoffman had written about how time extended under LSD when he was cycling home after his accidental exposure. And it struck me at that moment that this is a very fundamental insight into the way the brain works. If you can change time that profoundly with a drug, then I presumed you could do anything with a drug. And that's why I'm a psychopharmacologist. So that was quite a sort of founding influence on my career, I think. However, I went off to a place called Cambridge University, where this man had won the Nobel Prize along with Alan Hodgkin a few years before I went there. And this is Andrew Huxley. He defined the way in which action potentials worked. He produced the first mathematical model of how a neuron did something. It was immensely powerful intellect, phenomenal contribution. He's the founder of mathematical neuroscience. But as you all know, it was his half-brother, Aldous, who in some ways was the more interesting person, and of course the reason most of you are here is because the way in which Aldous promoted the concept of psychedelic research was so efficient and also so remarkable in terms of its linguistic qualities that it became very compelling to many people. So here he is. Aldous is the older half-brother of Andrew. He never got the Nobel Prize, but he never did medicine, of course. Some of you may not know. He wanted to do medicine, but he had an inflammatory process of his cornea, which meant that he couldn't look down the microscope, so he couldn't really study medicine. So he went off to do other things, but he was very, very scientifically oriented. And of course, this is the book that really put psychedelics into the public consciousness, the Doors of Perception. And I don't suppose there were many people who at the time knew of the work of William Blake, the great English mystic, who came up with this rather remarkable phrase: if the doors of perception were cleansed, everything would appear to man as it is infinite, for man has closed himself up till he sees all things through a narrow chinks of his cavern. And that, I guess, is the perspective of consciousness that Blake understood as being very limiting right back in the late 1700s, but which we all now, I think, accept as being not only true, but also verifiable using modern neuroscience. And I'm particularly compelled by these two individuals, Francis Crick from the UK and Gary Mullis from, I guess, just up the road. Was he in Berkeley? I can't remember. But these are the two individuals these are the two most important Nobel Prizes in the history of medicine. And they were both gained under the influence of LSD, where these two individuals used it to solve what at the time were insoluble problems. So working out the crystal structure of the double helix is not trivial. And in fact, it was very difficult. But one suspects that Crick got insights from taking LSD when it was normal, when it was legal, of course. And one of the real challenges to us today is the fact that the illegality of these drugs has profoundly distorted research, and he's continuing to do so to a point where I think it's actually one of the greatest insults to modern research. I think it's one of the greatest scandals. In fact, it's hard to think of a greater scandal, although it's possible that the Bush block of embryonic stem cells was of comparable size, but that didn't last as long as the bans on these drugs. And I'm going to give you another quote, which hopefully you all familiar with, which is this one from Einstein, that no problem can be solved from the same level of consciousness that created it. And that's given me a bit of hope that maybe we can actually eventually overturn some of the ridiculous prejudice against these drugs. So as some of you, I guess, are familiar with, before LSD was banned, there were over 1,000 human studies. I think there's been one since. I'm not even sure that's published, actually. And in the UK, there's never been a study on LSD. Till we started doing psilocybin research, there hadn't been any. There have been 2 for MDMA. And I've been promoting the concept of scientific enlightenment in relation to these drugs, and I managed to convince one of the editors of Nature Neuroscience Reviews that this is a serious challenge, a serious issue in relation to neuroscience. And this is a paper that I've written with Les King in the UK and Dave Nicholas, who's here. It's coming out in a couple of months in Nature Reviews Neuroscience, and I'm going to use this to springboard a campaign to get the law changed so that researchers can easily access important drugs to answer important questions. And just to emphasize that maybe you guys were here even before Aldous Huxley. Here's William James, of course, the father of American psychology, pointing out that there are different forms of consciousness. And I think some of these insights were gained from his knowledge of the very early anthropological studies of different ethnic groups using psychedelics. And I think Dan Grove is here, and I think this is a wonderful quote, and I use this in all my lectures now. Psychedelics used responsibly and with proper caution would be for psychiatry what the microscope is for biology and medicine, and the telescope for astronomy. And it is absurd that we haven't been allowed to use them, and I think it's held back research in many areas. So this is what we're doing at present. You've heard Robin talk about those 3 psilocybin studies. We have an LSD study about to start, provided we can get the compound. We've got an MRC-funded trial for psilocybin in depression, which where getting the compound is proving challenging. We've also got another MRC study funded to do look at the psilocybin as a model of psychosis, as Robin was mentioning, the failure of the default mode network to separate from the task positive network. We've talked about the MDMA study. I'll mention that briefly, and we're also quite interested in using cannabis also in MRI and MEG to explore similarities and dissimilarities of those different drugs. And we have NHS approval to do an MDMA study in treatment-resistant PTSD. And Ben Sessa, who's in the audience, has led that, although we haven't managed to get it funded. The first funding body turned it down. But the fact it's been approved by the National Health Service is actually at least a start. So why do we want to do these experiments? Well, I think there are 3 reasons. I mean, the first is I think we need to understand how the drugs work, and these are phenomenally important, I would say necessary tools to understand consciousness. At a more mundane level, they allow us to address questions about what the 5-HT2A receptors are doing in the brain, and the fact that there are so many of these receptors so densely expressed in these really interesting and important brain regions tells us that they're likely to be important, and therefore we should study them. And of course, for me as a clinician, then there's the really interesting possibility that these drugs may have treatment potential. And Robin showed you this completely paradoxical effect. When we started doing this experiment, we'd all expected that psilocybin would increase brain blood flow, at least in regions such as visual cortex, where it might be correlated with the interesting colored geometric hallucinations. And when you find something exactly the opposite of what you predict, then as a scientist, you usually know you're right, because there's no bias, there's no encouraging the data to get a significance. This is exactly opposite what we predicted, and therefore it was, we thought, likely to be true. But we went on and replicated it. He's shown you this as well, the uncoupling of the default mode network as well. So these were profound changes, as I say, unpredicted and profound. And those changes in the default mode network were, I think, are fascinating because of this emerging evidence on what the default mode network is doing. And Robin has shown you this, the way the network is concentrated in the anterior and posterior cingulate cortices, acting as connector hubs for the brain. But as he also mentioned, one of the first challenges we met was this challenge. Referees simply said, well, these drugs are serotonergic drugs. Serotonergic drugs change brain blood flow because, for instance, the triptans are serotonergic drugs. So this is all an artifact of changing blood flow. I mean, we did argue that actually it would be quite interesting simply to know that changing blood flow in those regions produced such profound alterations in consciousness. It wouldn't matter really how it did it. But anyway, people didn't like that because neuroscientists liked things to happen in the brain, not in the blood. And that's why we went on to do the MEG study, because MEG essentially is a measure of electrical activity. And as Robin showed you, essentially the same findings, this profound perturbation of activity, particularly in the posterior cingulate cortex across all the different frequency ranges, and the anterior cingulate cortex in a higher frequency. So that really does clinch it. This is a profound effect on brain function. So how does it do it? How does psilocybin do this? And he mentioned that it's the stimulation of 2A receptors, which seems to be common to all psychedelic drugs, with psilocybin having a potency of about a 20th out of LSD. And these receptors are profoundly concentrated in these areas of the brain that make up the default mode network. And maybe to address one of the questions that was raised from the floor, the way we're conceptualizing what these receptors are doing now is that they clearly don't affect, unless perhaps they're extraordinarily stimulated, they don't affect memory, they don't affect even the ability to respond to perceptions and sensory inputs, but they certainly change the way in which you integrate sensory inputs with other experiences. So it seems to me that the 5-HT2A receptor has got something to do with the kind of valence of emotion. And the other major receptor in cortex, of course, is the GABA receptor, which changes the level of arousal from sedation in coma through to hyperexcitability. So I think we have a two-dimensional model now of those elements of consciousness. And the question of why you would get an inhibition of brain blood flow when you're exciting these 2A receptors on the layer 5 pyramidal cells is explained by the fact that there are also a large body of these so-called fast spiking interneurons which are activated by the pyramidal cells. So when the pyramidal cells fire, they stimulate the fast spiking interneurons, which also have 2A receptors on them as well. And very often in brain function, when you stimulate something, there is a net overactivity of inhibition, so that the net effect is an inhibition of function. We see that with transcutaneous magnetic stimulation. The net effects are inhibitory because of the huge density of inhibitory interneurons in the cortex. So that's what's going on. There's a massive firing and then an even greater inhibition. So at the molecular level, we can explain it, but what does it mean in terms of potential therapeutics? And we were particularly struck by the attenuation of activity in this region here, the medial prefrontal cortex, or the ventral medial prefrontal cortex. And the reason we were interested in that is because over the last decade, it's become clear that a number of different treatments of depression suppress the activity in this brain region. There you go, SSRIs, CBT, sleep deprivation, ECT, placebo, deep brain stimulation, ketamine. And I want to just spend a little bit of time on this study, the one I had in Maybury, because I think this is truly a remarkable example of how neuroscience has directed interventions in a meaningful way. And she was a neurologist. She was working at Emory at the time, and she essentially did these were PET studies looking at brain metabolism, and she showed that in her patients with treatment-resistant depression, there was overactivity, increased metabolism in this brain region here called CG25. And she referred it back to, again, the writings of William James, who suffered from depression himself, and pointed out that depression is a positive and active anguish, a sort of psychical neuralgia wholly unknown to normal life. And this positivity, she inferred, was due to overactivity of this region. And because she was working in a center where they developed neurosurgical techniques for Parkinson's disease, she was able to persuade neurosurgeons to stick an electrode into here and switch it off. And that switching off produced in some people quite profound improvements in mood. So you go from overactivity to underactivity in the people who responded to deep brain stimulation for depression. And if you stayed well, it stayed shut off. So this was a fascinating conceptual advance in terms of regulating brain function using, obviously, a relatively extreme approach, neurosurgery, but one that does prove the concept of inhibiting brain function may result in a good outcome. And she also then went on to show that people who recovered on SSRIs also had reduced activity in the same region. So it seemed to us that, well, if we could produce an equivalent effect using a single dose of psilocybin, that would not only be enormously cheaper, but also it would be obviously much safer, etc. So if we could mimic the beneficial effects of deep brain stimulation with psilocybin, then that would be, we think, quite a major advance. And that study is pending, but as some of you will have heard, it's proving quite difficult due to the particularly complex regulations we have in Europe over the manufacture of drugs for clinical trials, to actually find any company that can make psilocybin to the quality that the European regulators require, and it also have a license to make it. So we're caught between two very big rocks at present. So why might there be overactivity in brain regions as a result that could be amenable to psilocybin? Well, I just want to show you this study from a group in Oxford who looked at the density of 5-HT2A receptors and showed that in depressed people, there's a higher density. It's almost as if there's an upregulation of these receptors, possibly in an attempt to compensate for some deficiency of serotonin. And there's also this data from the group in Toronto showing again that the more 5-HT2A receptors you can measure using PET, the greater the pessimism in people with depression. And then finally, just a couple of other words about the MDMA trial, because this was a study that was funded by television. We could not get any standard funder in the UK to fund work on a recreational drug. But eventually the TV company came up with the money, and we were able, therefore, to do it. And the study was a remarkable study, not only in terms of the fact we've got some fascinating data using imaging, but also we also were able to show it on TV and show people what a research in imaging looks like. And it's still available. If you go onto Channel 4 website, you can still download it. It's the most downloaded program ever on that particular TV channel. It also, MDMA, Robin didn't show these data, also produces attenuations in brain blood flow, not dissimilar to those you see under psilocybin, particularly in the thalamus. And the thalamic changes correlated well with the subjective intensity. And also connectivity was reduced, not as profoundly so as with psilocybin. And one of the real challenges now is to tease apart the differences between these two drugs, which clearly have different targets, but in the end, both presumably produce stimulation of 5-HT receptors. But it's not going to be easy, and here's an example. This is one of our politicians, And he's challenged, every time we have gone public with our results, he's asked questions in the House of Parliament. He's allowed to do that. It's called parliamentary privilege. He can say anything he likes about us without any kind of comeback. And after the first study, the psilocybin study, he asked why we were allowed to use an illegal drug in a scientific study. And after the MDMA program, he intimated that, well, you can read it, what license was held by her, that's the Home Secretary, for drugs that are used in the study, what's the process of revoking such licenses and how this process will be initiated. So I think you can see that's a pretty serious challenge to our ability to conduct this research. I think that's a bit of a microcosm of the kind of approach that's actually unspoken across the country. People don't want it to happen for no very good reason other than these drugs are illegal. And I'm going to finish by giving you another quote from Aldous Huxley. Great is truth, but still greater from a practical point of view is silence about truth. Facts do not cease to exist because they're ignored. By simply not mentioning certain subjects, totalitarian propagandists have influenced opinion much more effectively than they could have by the most eloquent denunciations. And that's exactly what's happened to this research over the last 50 years. And it's time that the neuroscientific community was enlightened and moved this field into the 21st century. So if you want to read any more about this, you can read my book. All the proceeds go to a charity which tries to tell the truth about drugs. And I'll finish by just saying that we are going to have a little mini version of this in the UK on the 12th of June. We're going to have the first UK psychedelics conference probably ever. And if you want to come. Thanks. Cheers.
Thank you so much. Thank you, Professor Nutt. We have time for some questions. If people would like to step up to the mic with any questions or comments. There we go.
No one wants questions. No. It's better not to be associated with me, actually, because...
No. Here we go. Thank you, sir.
Thanks for all the work you're doing in Britain towards rational psychedelic use. Epigenetics, have you, I believe that's going to become a factor in some of these areas. Do you have any information on that?
Well, we don't do any, studying, we haven't done any, even considered doing epigenetic studies in humans yet. I don't think the technology is there. I suppose one could in animal studies, but yeah, there will be changes, I'm sure.
Yeah.
I'm sure there would be, I'm sure those layer 5 cells will show epigenetic changes following a single dose. That's a really interesting thing to do. Well, we don't have that technology.
You mentioned that people with depression have higher densities of 5-HT2A receptors. Have you seen any connection with that and maybe a high tolerance in people with depression?
That's a really interesting question. Yeah, we haven't administered psilocybin to people with depression yet because we haven't crossed the, that threshold for getting the drug for clinical use. We would love to do that. We'd love to scan people, look at the number of their receptors, look at responsivity. The trouble is PET scans are hugely expensive. You're talking $20,000 a scan. We don't have that kind of money, and we don't have a 2A tracer currently running in our lab. But at some stage in the next year or two, I think we will have a 2A tracer. Then if any of you wants to fund that research, let me know. We'll do it. All right.
Speaking of funding research, has the success of Drugs Live on Channel 4 continue the conversation about funding further research at all? Any of your other studies?
Well, we are negotiating to do another study this year with them. Yes, and that's hopefully we can get it done. Yeah, but that won't be with psilocybin. That'll probably be with different sorts of cannabis.
Thank you.
My location in Florida, in the sensitive political area, the I-4 corridor, gives me the opportunity to meet with a lot of politicians coming through, and lets me work as a psychedelic advocate and lobbyist. Are there any names of people I can consult and write to get better information?
Maybe we can talk afterwards. I'm not entirely sure what you were saying, but you can ask me afterwards.
The effect of MDMA has been tied to upping the oxytocin level.
Yeah.
And one gets many of the same effects with psilocybin.
Yeah.
Camaraderie going up, empathy going up, trust, contentment. Has anyone looked at, or have you looked at perhaps the oxytocin level going up?
So, yeah, we've done that in the MDMA study. I haven't got the results. I haven't got the adequate assays of the oxytocin done yet. I'm not happy with the reliability of the assay. We have not done it with psilocybin. I don't know why. Why haven't we done it? It's just a bit of a chore. I mean, we've tried to avoid the need to have needles in people because that does change the way in which they do they experience the scanning and that. But we could do. I mean, and it's a very good question. Has anyone done? I don't know if anyone's ever done psilocybin in. You guys? No? And oxytocin is, it's a very difficult assay, oxytocin, though, which is why I'm reluctant to say anything about what the results are with the MDMA. Some people it goes up a lot, but it's very unreliable. Yeah.
I was just wondering what you think about salvinorin A, which has some overlap in the phenomenology with the serotonergic agonist, but does not affect serotonin receptors in any way.
No, I think it's a really interesting question, and I think it would be fascinating to study that drug too. I mean, similarly, ketamine. I mean, ketamine. There are some studies with ketamine. I mean, the functionally utterly different, but one thing, there is some convergence in terms of uncoupling the anterior cingulate from posterior cingulate. So, but salvinorin would be a great experiment to do. Yeah, we were wondering about doing that if we can get the compound and be allowed to use it legally. Yeah.
Hi, thank you for your talk, both you and Robin were really interesting. I have two questions. One of them is, in your psilocybin study, were your subjects psilocybin naive?
No, they're all psilocybin experienced. We wouldn't be allowed to give it to a naive subject. Okay.
And my other question is, it appears that the resting state scans of psilocybin may give you different results if you were looking at psilocybin-assisted psychotherapy. Can you comment on that?
Was there something I missed at the meeting then?
Oh, no, I was just curious if you think that you may get different results from the brain
okay, so I
scans.
suppose the current thinking is this, is that in depression you'll have, the DMM will be over-connected and that'll relate to the degree of negative ruminations that patients have, and that you will uncouple that, and that will stay uncoupled. And we do have funding to do the scanning as well as the clinical trial in depression. So we'll look at that and see if we can show that there is an enduring effect. Yeah.
Is there any reason to expect you would get a different result if it was psilocybin in the context of psychotherapy?
Well, I'd hope not. But I mean, one would hope that the psychotherapy might improve the response. But one doesn't know. And of course, I don't think we actually know whether the sensitivity to psilocybin will be different in people who are depressed. I mean, you can argue it both ways. So in fact, in the depression study, we're going to use a low dose first, just in case. But if anyone here has got experience of using psilocybin in depressed people and can reassure us that they're not super sensitive, let us know.
Thank you. Thank you, Professor Nutt. Please help me thank Professor David Nutt.